A very good morning, class. So today we are going to start with the voids and a very small idea I have already given in my previous video, and I hope that at least little bit knowledge you people have about the voids. So let's explain. Let me explain this. Okay. So void is the empty space, the vacant space between the constituent particles in a closed packed structure. Void in a solid state means the vacant space between the constituent particles in a closed packed structure. If for like 1 second, if I say this, like, see, in this, suppose that this is the unit cell, okay, and in this unit cell, if I'm going to put the sphere, atom is in spherical shape, yes. So let me put this atomic sphere if I'm putting it, okay, it should be like attached. Anyway, you just keep it anyway, either you put it in the depression or you just put a one upon other, okay. So what will happen, you will get some empty space, isn't it? Let me show you with the other color, and already I have shown you with this that 3D animation. So this empty space, ये जो empty space है, this is called void. You cannot fit another sphere in this, isn't it? This is the smaller than the void, that sphere shape, so you cannot put any other sphere in that. Clear? And it out. So that is called voids. Voids are of two types, that is tetrahedral voids and the octahedral voids. Already I have explained in my previous video about this, so this is just to write down. Okay. Tetrahedral voids, in the cubic closed packed structures, spheres of the second layer lie above the triangular voids of the first layer. Is it quite clear? Samjho that cubic closed packed structure, spheres, whatever the spheres of the second layer, that will be put in the triangular void of the first layer. Each sphere touches the three spheres of the first layer. That means on the same layer, it touches the three sphere and one from above, you can say. So by joining the center of these four sphere, three and one layer above, I should write, and one layer above, okay. Okay, by joining the center of these four sphere, that means three in the same plane and one above that, it forms a tetrahedron, and the empty space left over by joining the center of these spheres forms a tetrahedral void. So did you get that? Tetrahedral void, when it will form? Okay. Now, in the closed packed structure, the number of tetrahedral void is 2 times than the number of sphere. That I already have explained. Okay. So let the number of sphere be n, then tetrahedral void will be 2n. And you can see that this blue one is in one layer, and I'm going to put the another layer on the like exactly above on the depression of this first layer. So if I'm doing in this case also, it is giving you a shape like triangular shape it is giving, and this triangular shape is called tetrahedral void. Okay, it will be considered as tetrahedral void. Why? Because its shape is tetrahedron. It is attached with the three particles, three in same layer and one above this. Okay. Now the octahedral void. If I'm talking about the octahedral void is adjacent to the tetrahedral void. You can find octahedral voids also. Okay. So now, what are the octahedral void? When the triangular voids of the first layer coincide with the triangular voids of the layer above or below it. Did you get that? What it is? That means it is going to be A8 AA type. Okay. That means whatever the layer we are keeping, whatever the depression is there, it will remain same, and the next layer also will keep on the sphere, not in the depression of that layer. Okay. So then in that case, it will give you a double triangular void, double triangular shape. I will show you in further slide. It will give you the shape like this. This is called double triangular. Okay. So if it is double triangular, then it will be called as what? Octahedron. Okay. So see, when the triangular voids of the first layer coincide with the triangular voids of the layer above or below it, we get a void that is formed by enclosing 6 sphere. Okay. And the vacant space formed by combining the triangular voids of the first layer and that of the second layer are called octahedral. This void is from above layer and this void is from below layer. So it gives a double triangular, that means octahedral void. Okay. And formula is, if the number of sphere in the closed packed structure is n, then the octahedral void will be equal to number of sphere present in that. Number of sphere means ranking of the unit cell. Okay, that is denoted by Z, or you can say that the n. As like FCC it is n, FCC it is 4, CCP it is 4. Yes, so similarly. Now see this. This one is the layer 1. Okay, this is the layer 1. And if I'm going to keep this above this, this will give you octahedral void. It will be shaped like this. Okay, so this is going to give you the double triangular. This triangle 1 and this is the triangle 2. So that's why it is called octahedral, because it is attached with a 6 sphere. So here is the next slide, that is location of tetrahedral and octahedral voids. How we will identify that where are the tetrahedral voids occur and where the octahedral voids occur. So see, there is a diagram. You can see that there is a body diagonal. If you check in that cube, it has 4 body diagonal, isn't it? Just assume 4 body diagonal for that room in which you are sitting right now. Okay, so 4 body diagonal. So there are 2 tetrahedral void at each body diagonal. So what will be the total number of void? That will be 2 into 4 is equal to 8, yani ki 2n. That we got. Yes. Okay, now the octahedral void. This is the position that you are supposed to learn, that it is present at all the edge center, along with that one in the body center. Okay, so if you will check that, there's the edge center. This is octahedral. Yes, you can see octahedral, and this one is in the body center. This is the edge. You can see this is the edge over here. This is the edge over here. And here, if you are confused in this body diagonal, how it is, let me show you. The one body diagonal is like this. Yes, till here. And the second body diagonal is like this in this case. So the 4 body diagonal, 2 here and 2 here. So 4 body diagonal, and that's why total is 8. Okay, so come here. I was explaining that this one is in the body center, and all these are at the center of the edge. So if we check that, what will be the exact number? So according to that, as we were finding the number of atoms, we will find this also. So 1 upon 4 is the contribution of the edge particle, isn't it? And total edge are 12. So this becomes 3. And in the body center, there is a 1 and its total whole contribution is 1. So that's why it will be 1, yani ki 4. And this is coming, and that means for CCP, we will get that what is equal to number of atoms will be equal to rank. That means 4. Okay. So now we will solve some question based on this voids. Okay. So here's the first question, that a solid is made up of 2 elements x and y, and which are in the FCC arrangement. That means number of atoms is equal to n, or you can say that the 4. Yes. And y atoms occupy all the octahedral sites. Octahedral sites. Right now I have explained that where is the octahedral sites. Octahedral sites are present at the edge center and along with that one in the body center. And octahedral sites की value क्या होती है? N होती है. Got it? And at alternate tetrahedral sites. Alternate tetrahedral sites, that means it is in the body diagonal. So this is total tetrahedral site is 2n. So if we will talk about the alternate, it will be also n. Yes. So what is the formula of the compound? So let me show you. This is the atoms of X forming FCC. So X के atom कितने हो गए? 4. We got it. And how we are we know this 8 corners and 6 faces. So its contribution is 1 by 8 and its contribution is 1 by 2. Along with this, we will get the 4. Tetrahedral sides जो है वो total 8 है, होते हैं 2n as it is. Let me write over here 2n. Okay. So if I am talking about the alternate, it will be at alternate. So number of y atom will be half of this, यानी कि 4. And octahedral side, so it is 4 only. So number of y atom, because y is present at the octahedral sides as well as alternate tetrahedral. So octahedral में कितने हो गए? 4 that I have written. And alternate tetrahedral में कितने हो गए? Total tetrahedral is 2n. But alternate tetrahedral, if I am talking about, it will be 4. So total y atom कितने हो गए हमारे पास? 8. Isn't it? 4 and 4, 8. And x kitne hai? 4. So what will be the formula? x4 y 8. Or we can say that x4 y 8, or we can say that x y 2. Yes, got it? It should be like this. Okay, so now let's move to next question. The next question is, a solid is made up of two elements, x and y, are in FCC arrangement. Again, the one which is octahedral site, and that we have arranged this. So x and y are in the FCC arrangement, and y atoms occupy all the octahedral sites and the alternate tetrahedral sites. What is the formula? I think it is same, sorry. Okay, so here is the next question, that is, in a solid oxide, ions are arranged in CCP. Clear? So CCP, that means N is equal to 4. 1/6 of tetrahedral void are occupied by cations A. So let me explain you thing. Cations A and 1/3 of octahedral voids are occupied by cation B. What is the formula of the compound? So don't forget, it's not AB only. AB, along with this AB, there is one oxide also. Or quite clear, if you are confused, just check the words. This is also cation and this is also cation. So it is not possible that only the compound is made up of only two cations. Okay, so some anions should be there. So ye bache generally they forget about this, and they ignore this, and here they make the mistake. So okay, so I'm just telling you one thing, that if the anion is there, anion size is bigger, so it will always be at the corner. Okay, don't be like, it will never be in the void nahi hote. Void mein cation ho sakta because cation size is smaller. Yes, so void will be always occupied by the cation, or you can say that the cation exists in between the void only, while the anions they exist, or they occupy the corner positions. Okay, so here we can say that if oxide we are talking about, so we can say N is equal to 4. Yes, CCP arrangement we can say. So now this is number of oxide ion forming CCP 4, and how it comes: 4 at the corner and 6 at the face center. Okay, chaliye, number of tetrahedral void is equal to 2n, that we know that 8, and number of octahedral void is equal to n 4. So it is said that cation A is occupying 1/6 of that 1/6 of the tetrahedral void. What is the tetrahedral void? 8. So 1/6 of tetrahedral void will be 8 by 6. Yes. Next is one cation B is occupying 1/3 of octahedral void. Octahedral void क्या है हमारे पास? 4. तो 4 by 3 हो जाएगा, isn't it? So this is 4 by 3. And if I will take the formula, A, B and oxygen is there, oxide is there. So A ratio is 8 by 6. Yes. B is 4 by 3. And oxygen is 4. Here we got. Okay. So just make it simpler. Multiply by 6 to all. So this will be 8, and this will be 8, and this will be 24. Again simplify, it will be 113. So formula will be AbO3. Got it? Any doubt in this? So ये आपको ध्यान रखना है, if it is oxide, if it is ions, okay, anion, so it will always be CCP, and number of atoms will be 4. We will consider. Clear? चलिए, okay. Anions cannot occupy in the voids. Voids में नहीं आएगा, बस इस बात का ध्यान रखेंगे. Okay, now the next question is, a solid is made up of two elements P and Q. A atom Q are in CCP. यानी कि this is 4. Q is 4. While atom P occupies all the tetrahedral void. It's so simple, isn't it? Tetrahedral void will be 2n. यानी कि 2 8 2 into 4 यानी कि 8. So it will be atoms occupy 8 corners, 6 faces center, so forming CCP. Hence the number per unit cell will be 4, that I have already told you so many times. Yes, and the tetrahedral void is equal to 2n is equal to 8, and where the tetrahedral void occur, that it is written over here, 2 at each body diagonal. So number of P atoms we got 8, and Q atom is 4, isn't it? So the formula will be P8 Q4, that means P2Q. Any problem? P8 Q4, or you can say simply P2Q. Yes. There is the next question, and that is, ferric oxide crystallized in a HCP of oxide ion with 2 out of every 3 octahedral voids. This is important thing. You have to consider this point. Okay. void occupied by ferric ions. This is quite clear or always understood that cation will always occupy the void only. Okay, an ion can never be fit into the void because of bigger size. Okay. Okay, chaliye. So let's do this. Ferric oxide crystallize. Now we have to make the formula. So in a closed packed arrangement, there is one octahedral site corresponding to each atom constituting the lattice. This one is clear. Closed packed arrangement, there is a one octahedral site corresponding to each atom constituting the lattice. Therefore, the number of oxides ion per unit is HCP. This is HCP. No? It is not what at the cubic CCP. This is HCP. So in this HCP, we have to consider that the number of atom will be 6, and that means and oxide ions per unit cell जो होंगे वो it will be 6 corner and 6 part पे होंगे वहाँ पे. ठीक है. Number of octahedral void जो होंगे वो पर this is I have explained in that octahedral site in the HCP will be one, only one in the whole lattice. So this is 6 into 1 is equal to 6. And then iron oxide, if I am talking about that iron, so it is said that out of every 2 out of every 3 octahedral, that means 2 by 3, isn't it? So 2 by 3 and octahedral void are 6. So 6 into 2 by 3, it will be equal to 4. So what will be the formula of iron Fe4 and oxygen 6, isn't it? So the ratio will be Fe2O3. Got it? Any issue? Any problem? Got it? So this is the point you have to learn, that octahedral, if I'm talking about the CCP, the octahedral void will be N, equal to number of atoms. Okay? And here also the number of atoms जितने होंगे जो coordination number जो number होगा उसी के बराबर होंगे. But यहाँ पे याद रखना कि this is HCP, so the octahedral void will be 6. Clear? Okay, and it is its contribution in one lattice, one unit cell is complete 1. The whole unit cell it is 1 only. Okay. Chale, now the last question for for today's video. This is in a solid AB. A atom have CCP arrangement. Again, that means N is equal to 4 aa gaya. Okay, and B atoms occupy all the octahedral sites. That means B is also 4 over here. According to this, if all the face-centered atoms along one of the axes passing through body center are removed, then what will be the resultant stoichiometric of the compound? Think of it. I'm giving you 1 minute. Just think of it and then I will explain. Okay. So let me explain this. This is quite clear that it is A is equal to 4 और ये 4 क्यों होता है? Because of this 8 corner and 3 faces. 3 from 6 faces center. Clear? Got it? अच्छा, अब मैं यहाँ पे I just want to explain that octahedral void. Whenever we were like covering this and what we say octahedral void, I have explained you that it is on the edge center. That means 12 edge center, and their contribution is 1 by 4, and 1 is in the body center. Clear? Any problem in this? So that was comprising the octahedral void 4. अब यहाँ पे क्या कह रहा है? If all the face-centered atom along one axis passing through the body center are removed, so जो that octahedral void is not on the face-centered. face पे तो है ही नहीं. Clear है point? ध्यान से समझो. I'm saying that octahedral void जो होता है, that is present at the what? At the edge center. Let me write over here. Edge center and 1 in the body center. Yes, quite clear. Body center. ठीक है. So अगर फेस सेंटर्ड के एटम को निकाला जा रहा है तो इसमें कोई फर्क नहीं आएगा. Will there be any changes? No. So that means B atom will be, जैसे octahedral void होता है वो N के बराबर होगा, तो B will be exactly N. I have written, but let me write this. B will be exactly N, and this is not going to change. Clear? So change कहाँ होगा? अब ये देखो, नंबर ऑफ ए एटम जो कि सीसीपी फॉर्म कर रहा है, दैट इज ड्यू टू 8 कॉर्नर्स एंड 3 फ्रॉम 6 फेस सेंटर. क्लियर है बच्चे? ये रहा फेस सेंटर. तो इफ आई एम गोइंग टू रिमूव द फेस सेंटर along one axis, that means it is going to change what? Axis passing through the body center are removed. Okay. So it is going to change the number of atoms of A. Is it okay? So number of atoms अगर हम यहाँ 4 करते हैं तो how we get that 8 into 1 by 8. Yes, 8 into 1 by 8. Clear? And we get plus we get 6 into 1 by 2. Yes, clear hai bachche? Now what will happen? One axis through the face, like two face center jayega. So now instead of this 4, it is going to be decreased up to what? 4. Yes or no? Clear? This is 4 into 1 by 2, and that is 8 plus 1 by 8. Yes, any problem in this? So total, instead of being 1, like although it is CCP, but the A will not be equal to 4. क्या हो जाएगा ये? It will be 3. Got it? Any problem in this? So formula will be what? A3B4. So here let me show you. This is quite clear. Number of A atoms left in the unit cell कैसे आया 3, that I have explained over here. Yes. And then number of B atoms occupy all octahedral void, that is not going to change. So it will remain like that 4, and the formula will be A3B4. And the stoichiometric is 3:4. I hope you got this question. Yes. So this question is little tricky, but not so tough. It's not rocket science. So okay, class. I hope that you got the concept of void, and where the void, octahedral void occurs, and where the tetrahedral voids occur, where the cation can exist, where the which place will be occupied by the cation and which place will be occupied by the anion. I hope all these are clear. Okay, so in the next video we will do about the radius ratio and all that, and then after packing fraction wire. So just go through with the video properly, make short notes, and enjoy your study. So we'll meet in next video. Till then, thank you, class.